Structures 2 Design Project, Nevin Blazika and Thomas Haywood, Group 13. The aim of this course is to develop an understanding of the structural design process, superstructure, to help work effectively with engineers and other consultants when you are engaged in the work or field. A key aspect of working with structures in the construction industry is being able to think critically about potential risks and issues, design solutions to respond safely and within the parameters of Australian codes and regulations, and then be able to communicate your ideas with confidence. There are two parts to this assignment. Both of these involve critical thinking about an issue or potential issue that is reflective of what might occur within the construction industry. The following report establishes how to develop an understanding of a structural design process, focusing on structural loads and paths to design specific structural members of a domestic shed. Multiple different structural elements of this given domestic shed project are identified, including roller supports, pinned, bolted, and welded connections. The possible loads in this domestic shed include both live and dead loads. There are two main components in the process of a structural design. These are load types and connections. Through both of these, the basic design of the shed is able to be developed. Load types are the type of loads in which are applied to the shed, whereas the connections support and transfer these loads. The most commonly known loads in construction are dead loads and live loads. When talking about dead loads, throughout the entirety of a structure, the dead load is continuous with the roof of a structure being measured as part of the dead load. The floor surfacing materials as well as fixtures such as plasterboards, cupboards and walls make up these components in which are the dead load of the structure. Also in that is the weight of the actual structure itself. If fixed into a position where it can't move, everything inside of the structure, including the materials, are then part of the dead load. Due to having the known dimension as well as weights of the materials in which are utilised in the structure, the dead load can then be calculated in a precise manner. Live loads are within the structure. All of the moving objects are the live load. Depending on the usage of the structure itself, live loads can differ from structure to structure. An example would be that cars driving over a bridge would be the live loads on the bridge. Wind load. Wind loads, wind actions, can have a significant effect on a building's design due to the high wind speeds being able to seriously damage any structure if designed poorly. Wind is caused by changes in the air pressure, which is affected by temperature, sea level, and the amount of water vapor in the air. Wind travelling or passing over and through a building will create pressure, as well as compression and suction on the roof and walls of the structure. When designing a structure, external and internal wind pressures have to be accounted for in the design, otherwise this will lead to significant failure. In the images shown above, the arrows pressing against the walls of the building represent the pressure and compression created by the wind speed. The arrows being pointed outward represent the suction created by the wind as it passes over and through the structure. Depending on the direction of the wind, walls and roofs will be affected by suction, pressure, and compression. Roller support. As the majority of structures are exposed to lateral loads, roller supports are not able to deliver resistance to the lateral forces. Without fighting against the applied horizontal force, the roller support moves across the surface as the force is applied horizontally to the bridge. Most structures are exposed to lateral loads, and the problem arises as roller supports are not able to provide the lateral force resistance. As a result, this therefore means that the building and structure must have another type of support. Pin support. A pinned connection is subject to moment and opposes both horizontally and vertically. If the moment is fewer than the limit of the support connection, then the pin connection can oppose few measures of moment. This specific type of connection is generally used when joining sections or columns at the base, as these members prove to be a pivotal piece in the structure, limiting any loads directionally. The parameters of design for the project. Our group, Group 13, had a shed length of 12 meters with a 6.6 meter height and 6 meter width. Project design. The Space Gas was a program where we had to draw the frame and apply various loads that would affect the frame. The loads that affected the frame were bending moment, shear force, deflection, and axial compression. Bending and shear force and deflection were the things that mainly affected B2 and its design, as it's a horizontal member and component of the frame. C1 is affected by the axial force as the load travels from the top of the beam to the bottom, thus creating such a compression. To get these values and compare them to the manual calculations, both dead and live loads were applied to the beam to see, and B2 and C1 would then act under these different types of loads. Space Gas also helped us in identifying and understanding the mistakes that we had made whilst doing the manual calculations. As a result of this, Space Gas gave us a more accurate result and really helped us visualize how the loads affect a member component of the design frame. As you can see from the following slides, they were all the calculations throughout the design project, the rafter design and the column design. These were a lengthy process, but Space Gas was able to help us in identifying and achieving such accurate results. Overall, thank you for watching, and hopefully you are able to gain something from this.